Hi! In this video, I'll go over one of the new additions in FielDHub version 1.3.1, Sparse Allocation. I'll cover some theory behind it, as well as some reasons one might use sparse allocation in a multi-environment field trial, and we'll go over how to create a sparse allocation design using both the FielDHub app and the FielDHub package for R. Sparse allocation is a method for distributing genotypes or breeding lines in a field trial experiment across multiple locations. It can be a useful approach when seed resources are limited. This can also increase selection intensity and accelerate the breeding program by increasing efficiency. In a sparse allocation experiment, you specify a number of copies of each genotype, which is less than the number of locations in the experiment. Then, you generate a binary genotype allocation matrix indicating with a 1 if the respective genotype is in the respective location, and a 0 if the genotype is not present in the respective location. The design can be generated using either random allocation or the use of incomplete block designs, which is the approach that FielDHub uses. The new sparse allocation feature in FielDHub allows users to easily generate sparse allocation experiments using either the package for R or the FielDHub app. I'll start by showing how to generate an example experiment in the app, then I'll cover how to create an identical experiment in R using the package. Suppose we want to run a plant breeding field trial consisting of 260 entries with 4 checks across 5 locations. Suppose that in this experiment there's insufficient seed quantity to replicate the entries completely across all 5 locations, but there's enough seed to replicate each entry in up to 4 locations. Using sparse allocation, we can run such an experiment across 5 locations. We just need to replicate each entry fewer times than the number of locations. So, in this example, we'll replicate each entry 4 times. Now, I'll show how to generate a sparse allocation design using the FielDHub app. First, open the FielDHub app. Then, in the header at the top, click the Unreplicated Designs dropdown and select Sparse Allocation. Then, on the left side of the page, we have a list of options which specify the parameters of the design. The first option we have at the top of the page is to import a list of entries. If we choose this option, the entries list must be in a CSV file consisting of 2 columns, entry and name, and any checks in the experiment must appear at the top of the list. I have a file prepared that looks like this, consisting of 260 entries and 4 checks, which I'll upload for this example experiment. If you don't upload a list of entries, FielDHub will generate one for you. Then, the next 3 options are to specify the number of entries, checks, and locations in our experiment. The entry input should be the number of non-check entries. These are 260 entries, 4 checks, and 5 locations in our case. Next to the number of locations input, we have a box to select which location is displayed, once we run and randomize the experiment. Below this, we specify our number of copies per entry, which we said in the example would be 4, as it must be a value less than the number of locations. The FielDHub app will only give valid options in the dropdown here, so we only have 3 and 4 to select from. We ignore extreme values like 2 or 1. Next, we can customize the experiment with an experiment name, starting plot number, and location names, which can be given in a comma-separated list for multiple locations. I'll call our sparse allocation example experiment sparse example, and I'll enter 1001, 2001, 3001, 4001, 5001 for the starting plot number for each location, and lock 1, lock 2, lock 3, lock 4, and lock 5 for the name of each location. Finally, we can specify a random seed so that the experiment randomizes consistently across sessions. If you make a design, and then you need to replicate that design on a different computer, you can ensure that you get the same randomization both times if you use the same random seed. I'll set this to 1, 2, 3 in this example. Once we've specified the parameters for our design, hit the Run button, and FielDHub will generate a sparse allocation table based on those parameters. Then, in the right side, we see a large table with each entry in a row and each location in a column. As mentioned above, 1s indicate that the genotype is in the location corresponding to its column, and 0s indicate that it is not. We can copy, print, and save the table to Excel with the buttons at the top. After generating the sparse allocation table, we still need to randomize the design using an unreplicated design with checks on the diagonals. At the top of the output region, we can select the dimensions of our field, with options generated based on the number of plots in our experiment. I'll select 15 by 16 for this example. Once we set the dimensions for the field, hit Randomize. Then, on the tab Randomized Field, we can see the layout of the plots in a field of our specified dimensions at each location. Each cell contains the number of the entry that's in the plot, with the checks being in the various colored cells. Users can vary the number of checks in the field by selecting a different option in the drop-down menu at the top. Reducing the amount of checks adds some filler plots. There are buttons at the top to copy or save to Excel. We can display the layout for different locations by changing the Choose Location to View select box. For example, this is the randomized field for location 3. The next tab, Plot Number field, shows our field layout with respective plot numbers in each cell, starting from our input starting plot number, and following the plot order layout we specified, which is serpentine in our case. This tab also has buttons to copy and save to Excel. Finally, the last tab, Field Book, contains all the information about the experimental design, with entry numbers for each column and row in each location, and with our custom entry names from the entries list we uploaded. You can save the field book as a CSV with the Save Experiment button at the bottom of the input panel. Since this field book is for a sparse allocation design, not all genotypes are present in all locations. For example, we can filter by ND305 and see that genotype ND305 is present in locations Loc 1, Loc 2, Loc 3, Loc 5. We can also verify this in the Sparse Allocation table. We can create an identical experiment using the FielDHub package for R. To start, open an R terminal and make sure you have the FielDHub package installed with install.packages FielDHub. Then, we can use the Sparse Allocation function from the FielDHub package to create a sparse allocation design. We'll assign the output of this function to an object called Sparse Example. The first argument, lines, is the number of genotypes or breeding lines in our experiment, which is 260 in our case. The next two arguments are n rows and n cols, which specify the dimensions of our field by number of rows and number of columns respectively. In our case, this is 15 by 16. Next, the argument L specifies the number of locations in our experiment, which is 5 for this example. Next, we can specify the number of replications with copies per entry, which is 4 for us. Then, with the argument checks, we specify our number of checks as 4. There are additional arguments for customization, as in the app, such as experiment name for experiment name, location names for location names, and seed for random seed number. We can also enter a custom entries list with the data argument, which must be in a data frame with 2 columns, entry and name. Further reference is available in the documentation for FielDHub. Once we enter our arguments for the function, hit Run. Then our sparse example object contains 8 elements. The allocation table, which is accessible with sparse example $allocation, a list containing the number of plots in each location, accessible with sparse example $size locations, a description of the design parameters in the experiment, which we can get with sparse example $info design, a list of each entry in each location in the experiment with their respective names generated by FielDHub in the optimization process, which we can view with sparse example $listlocks, sparse example $layout random, which is the layout of the field with every entry number in their respective locations, sparse example $plots number, which is like layout random but contains the respective plot number instead of entry number, sparse example $data entry, which is the list of entry numbers by location, which will be the same as listlocks if an entries list is not supplied, and sparse example $fieldbook, which is the field book for the experiment, containing all of the information about each plot in the experiment across all locations. Listlocks is a list which is indexable by location, by adding $LOC and the number of the location we want to view, as in sparse example $listlocks $LOC3 to view the entries contained in the third location. We can also use view sparse example $fieldbook to visualize the fieldbook as a table in RStudio. We can use the generic function print to display information describing the design parameters, as well as the first rows of the fieldbook, as in print sparse example. We can also use the generic function plot sparse example to plot the first location layout. Users can plot other locations' layouts by passing the argument L. So, we plot location 5 with plot sparse example L equals 5.